Welcome to Study Loop.
For this question, we're asked to find the angle theta for a vector that has the following components for a, b, c, and d, where a of x and a of y had the same magnitude in every situation, but they're going to be a negative sign or lack thereof for the different situations here. Okay, so for part A, we have a of x is 2 meters and a of y is negative 1 meter. So if we just draw out our xy axis, a of x is 2 meters and a of y is negative 1. So the value here, let's do all of this in red, is going to come down something like this, right? Then we can find the angle theta that makes. But what we really want is the entire angle. We'll draw this in green. We're going to call this theta A, which is going to go all the way around from the beginning of the x-axis to that point, theta sub A. So just from our trigonometric identities, in general, let's just say this. In general, the tangent of the angle theta is equal to the opposite over the adjacent. So op over adjacent. So then theta is equal to the inverse tangent of opposite over adjacent. And we're going to use that in every single situation here. So our angle theta, not theta A, but theta is equal to the inverse tangent of the opposite value of that right angle. The opposite value is negative 1, right? Because we're told that a of y is negative 1, and that's the opposite, over the adjacent, which would be 2. So this comes out to equal 26.6 degrees. Right? And then there is a negative sign here. That angle is negative 26.6 degrees. So theta A is equal to 360 degrees, because that's what an entire thing would make, right? Plus the angle theta that we just found, which is negative. So it ends up being 360 degrees minus 26.6 degrees, which is 333.4 degrees. We can box that in as our solution for A. Okay. Part B. Now we have a of x is equal to 2 and a of y is equal to 1. So again, drawing this out, now we're going to be going in this direction, and we just want to find this angle. We're going to call that theta sub b. Okay, well, this time we can just simply use the trigonometric identity to find theta sub b. We don't have to worry about adding 360 degrees or 180 degrees or anything like that to it. We just find the angle theta sub b, since it's equal to the inverse tangent of the opposite over the adjacent. But this time, everything's positive, so it's just the inverse tangent of 1 over 2, which comes out to equal 26.6 degrees. We can box that in as our solution for B. Okay, part C. For part C, we have a of x is equal to negative 2 meters and a of y is equal to 1. So our resulting vector is going to be something like this. If we use our trigonometric identity for tangent, we'd end up finding that angle theta. But really what we want, and I'll do this one in green, is we want this angle from there to there, which we can call theta c, since this is part C. Okay, so first, the angle theta. Well, again, the angle theta is just going to be our inverse tangent of the opposite here, which would be our y value, which is positive 1, over the adjacent, which is our x value. It's negative 2. So this comes out to, again, equal negative 26.6. And then our value theta c is equal to 180 degrees minus or plus that angle theta, which is a negative angle. So plus negative is a minus value. So it ends up being 153.4 degrees. And we can box that in as our solution to part C. And then lastly, part D. And for part D, A of x is negative 2 meters and A of y is negative 1 meter. Everything's negative here. So it's going to be in the bottom right quadrant, or bottom left quadrant, something like this. If we use our trigonometric identity, we are going to find this angle, theta. But what we want, we want this angle that goes from here all the way to there, which we're going to call theta sub d, right? Since this is part D. So first, let's get angle theta. Same thing as we've been doing. This is going to be inverse tangent of the opposite over adjacent, which is negative 1 over negative 2. So this comes out to equal positive, since the negative sides cancel, positive 26.6 degrees. Okay, then theta d, like before, is going to be equal to 180 degrees plus theta. This time theta is positive, so it's going to be greater than 180 degrees, which makes sense, indicated by the drawing. And this is going to equal 206.6 degrees. We can box that in as our solution to D and the final part of our question.